Good morning, friends. Today I will discuss you some chemical properties of the hydrocarbons alkanes. It is in my continuation. In my last video, I explained you some physical properties. Today I will discuss you few chemical properties. You know, alkanes are the saturated hydrocarbons and they are non-polar in nature, so they are just reactive. But under certain conditions, it undergo substitution reactions. That is, in the case of the alkanes, if one of the hydrogen atom is replaced by some other element or by some group, that is known as the substitution reactions. Today, I will discuss you halogenations and its mechanism. Substitution reactions with halogens, that is chlorine, bromine, argon and fluorine. This reaction takes place under diffuse light, that is sunlight, or it is heated more than 500 K. Now if you see the reaction, methane, if we take methane, 4 hydrogen atoms are there, and in first step, methane reacts with chlorine to form the methyl chloride and HCl. Now in this reaction, if you see, one of the hydrogen atom of the methane is replaced by the chlorine. Now it is a continuous reaction till all the 4 hydrogen atoms they are removed by the chlorine atom. This CH3Cl again reacts with chlorine and form the CH2Cl, that is dichloromethane. The next step, one more hydrogen is replaced by the chloro, we get CH3, that is trichloromethane, and finally again one left hydrogen is replaced and form the CCl4, that is carbon tetrachloride. So we say that in the case of the reaction of the chlorine on the alkanes, it is a chain reaction and you get the mixture of the products. This same reaction can be carried out with the bromine also. But in the case of the reaction with iodine, that is iodination. Now when methane reacts with iodine, it forms first iodine methane and HI. Not say important reaction because here HI is a reducing agent and this reaction will become reversible in nature. So first we have to want to remove HI or we oxidize the HI. So this reaction takes place in the presence of an oxidizing agent. It may be iodic acid or the nitric acid, where this HI form is converted to the iodine and the water. So this HI is oxidized to iodine. So this reaction iodination takes place in the presence of a oxidizing reagent, that may be iodic acid or the nitric acid. Now third is fluorination, that is reaction of the fluorine. You see, it is a explosive reaction. It means fluorine when reacts with alkanes, it may explode. So in this reaction, this fluorine first is diluted by using an inert gas. It may be nitrogen or argon. To remove this problem, this reaction may be carried out with some fluoride, that is mercury fluoride, and a chloroalkane. Here we take the example of the ethyl chloride. When it reacts with mercury fluoride, when heated, it forms the fluoroethane and the mercury chloride. This reaction is known as the Schwartz reaction. So, Schwartz reaction means reaction of the fluorine with the chloroalkanes. So, chloroalkanes, that is ethyl chloride, react with methyl chloride to form the fluoroethane and the mercury chloride. This is known as the Schwartz reaction. Now, these reactions are with lower alkanes. Now, what will happen if we take higher alkanes? Here I take one example, sorry, that is propane. Propane, when reacts with sorry, chlorine and diffuse light, you see it forms as one is propyl chloride and other is isopropyl chloride. So the point is that higher alkanes, when react with chlorine and diffuse light, they form mixture of the products. So here in the case, a one hydrogen from the alpha carbon atom or the iso group, that is 2-chloromethane, that is isopropyl chloride. So in the case of the higher alkanes, as isomers are there, so we get the mixture of the halogens. Now the most important thing is that what is the mechanism behind the reactions. You see, in the case of the alkanes which are non-polar in nature, so these reactions they undergo by free radical mechanism. In this case, first step is chain initiation, that is fluorine molecules form the free radicals because covalent bond is there, so they form the free radicals. Second step is chain propagation. Here methane, one hydrogen atom is replaced by this free radical chlorine, and again a free radical, that is methyl radical, is formed, and this methyl radical then reacts with chloro free radical to form the chloromethane. So it is a chain propagation reaction. So in the case of the substitution reaction, mechanism is the free radical mechanism, where first chlorine form the free radicals, then chain propagation, methane form the free radicals, then the free radicals they join together to form the product. So this is the substitution reaction. In my next video, I will explain you some more chemical properties of the substitution reactions, that is sulfonation, nitrations. So if you like my video, please share and subscribe. Thanks very much.